You are about to hear something that identifies a massive misconception about our most recent interstellar visitor. While both 3I Atlas and the famous Oumuamua arrived from the dark void between stars, researchers at the Harvard-Smithsonian Center for Astrophysics are explaining that these two objects couldn't be more different. This digital reconstruction reveals that while Oumuamua was a silent, bone-dry mystery, 3I Atlas is a loud, active powerhouse currently lighting up our sky in late April 2026. A scientific disruption occurs when we compare their appearances. Oumuamua was famously shaped like a flat, elongated slab, nearly 10 times longer than it was wide, and it showed no coma or tail whatsoever. It was a dark traveler that left astronomers baffled. In contrast, 3I Atlas is a classic, vibrant comet. It arrived with a massive, glowing halo of gas and a dust tail stretching millions of kilometers. Researchers suggest that while Oumuamua was likely a shattered fragment of a planet, 3I Atlas is a pristine ice giant that has never been warmed by a star until now. The real mystery lies in their non-gravitational acceleration. A measurable recalculation of Oumuamua's path showed it speeding up as it left the sun, even though there were no visible jets to push it. This led to theories about it being an artificial light sail. However, for 3I Atlas, the push is obvious. Researchers have identified 3 distinct, symmetric mini-jets firing from its core. While this confirms it is an active comet, it has introduced a new intrigue. These jets are so perfectly balanced that they have allowed the comet to maintain a stable, wobble-free rotation, unlike Oumuamua's chaotic, tumbling motion. Every new simulation introduces a fascinating contradiction. Oumuamua was tiny, only about 100 meters long, while 3I Atlas is a behemoth, estimated by the Hubble Space Telescope to be up to 5 kilometers wide. Deeper implications suggest that while Oumuamua was a stealthy visitor, 3I Atlas is a messenger of light, carrying a chemical signature rich in methanol and carbon dioxide that hasn't been seen in our neighborhood for billions of years. As 3I Atlas makes its final exit through the constellation Gemini this week, we invite a calm appreciation for its unique nature. It isn't a repeat of the past, it is a brand new category of interstellar traveler. We haven't just found another Oumuamua, we have found its polar opposite. The Pan-STARRS survey recorded the first detection of 3I Atlas on July 14, 2025, as a dim point of light moving against the static backdrop of the Cetus constellation. Unlike its predecessor Oumuamua, which tumbled with a chaotic, violent eccentricity, this object maintains a rotation so precise it mimics the pulse of a quartz clock. Data from the James Webb Space Telescope and the Vera-C Rubin Observatory confirm that while Oumuamua was a shard of red-hued silence, 3I Atlas emitted a faint thermal signature that suggests an internal regulation of heat. What we are looking at is not a repeat of the past, but a variation on a theme we failed to understand the first time. The trajectory is not merely hyperbolic, it is intentional in its efficiency. It passed the solar gravitational well with a mathematical grace that defies the jagged, off-gassing behavior of a standard comet. Perhaps it is a derelict, or perhaps it is a scout that has finally found the right frequency. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. We find ourselves looking at such a king now, a cold, dark sovereign of the interstellar void. It makes one wonder if we are the observers or if we are simply the scenery being documented as it passes by. Take a breath and let the numbers settle. The distance between us is closing, and yet it has never felt further away. The data arrived in the quiet hours of a Tuesday morning, a series of coordinates that didn't fit the expected curve of a near-Earth object. It sat on the edge of the screen, a flicker of light that the software initially flagged as a glitch in the sensor array. But the glitch didn't disappear. It refined itself, sharpening into a definitive path that originated from the direction of the galactic apex. We often assume that the universe is a place of chaos, a messy collection of collisions and random debris, but when 3I Atlas appeared, it brought with it an unsettling sense of order. It was moving at 26 kilometers per second, a velocity that suggests it has been traveling through the empty spaces between stars for millions of years. It is a messenger that has forgotten its message, or perhaps we are a recipient that has forgotten how to read. The telescope turns, the sensor cools, the void remains. High atop the dormant peak of Mauna Kea in Hawaii, the air is thin, silent, and heavy with the scent of cold volcanic stone where the stars seem close enough to touch. Somewhere in the deep black between the constellations of Cetus and Aquarius, a dim point of light known as 3I Atlas drifted into our local neighborhood, moving with a cold, mechanical precision that feels almost deliberate. The Panoramic Survey Telescope and Rapid Response System, operated by the University of Hawaii, flagged the object on July 14, 2025, marking the moment our understanding of the void began to shift. You might remember Oumuamua, the tumbling shard of red rock that sparked 1,000 headlines back in 2017, but this is something entirely different. While Oumuamua was a chaotic wanderer, 3I Atlas arrived with a surface so dark it absorbs 98% of all visible light, and it maintains a rotation that does not wobble, does not drift, and does not decay. This object is currently traveling at precisely 48 kilometers per second, and unlike a natural comet, it has shown zero signs of off-gassing, yet its speed is increasing in a way that gravity cannot fully explain. Dr. Avi Loeb at Harvard has already pointed out that this non-gravitational acceleration is too smooth to be a random venting of gas. What if we are not looking at a rock, but at a piece of technology that has been coasting through the interstellar medium for 1 billion years, waiting for the right gravity well to wake it up? The ancient Sumerians spoke of a celestial body they called the winged disk, a traveler that returned on a cycle far longer than a human life, bringing with it a change in the tides of history. It makes you wonder if our ancestors were better at looking up than we are, or if they simply had less noise to distract them from the patterns in the dark. As you lie there listening, consider your own place in this vast clockwork universe, a small observer on a spinning marble, watching a visitor that doesn't even know you exist. Tell me in the comments where you are listening from tonight. Is the sky clear above your home, or are you tucked away beneath a blanket of clouds? The mystery of 3I Atlas remains unresolved, a dark mirror reflecting our own insignificance back at us. Deep within the refrigerated silence of the European Southern Observatory in Chile, the mirrors of the Very Large Telescope are currently tilted toward a patch of nothingness, waiting for the next pulse of data. On October 29th, 2025, a strange thermal spike was recorded coming from 3I Atlas, a warmth that should not exist on a dead rock so far from the Sun. It is a subtle irony that we spend billions of years of collective human evolution to build these machines, only to have them tell us things that make us feel like terrified children again. Unfortunate timing for those who wanted a quiet year in astronomy, as those two words are doing a lot of work right now. You might think that a comet is a simple thing, a dirty snowball melting in the heat, but 3I Atlas has no tail, no coma, and no dust trail. The conspiracy theorists are already whispering that it is a solar sail, a thin membrane catching the light of our sun to navigate toward the inner planets, while others suggest it is a derelict probe from a civilization that died out before our dinosaurs were even born. There is a myth from the Dogon people of Mali concerning a dark sister to the star Sirius, an invisible weight that governs the movements of the visible world. It mirrors the way 3I Atlas seems to pull on our attention without revealing its true face. As the countdown to its closest approach on December 12th continues, the scientific community is split between those who want to send a signal and those who are afraid of what might answer. You have to ask yourself, if you were walking through a dark forest and saw a flashlight beam in the distance, would you shout hello, or would you hide behind a tree? We are currently in the hiding phase of human history, observing from a distance and hoping our math is correct. This is not natural physics. This is activation. The object isn't just passing through, it is slowing down as it reaches the 3 astronomical unit mark. We may already be part of the experiment, a local variable in a very old equation. But the warmth was just the beginning. There is a pattern in the math that defies the very laws of entropy. Let us go further. If you look at the raw data coming out of the Vera C. Rubin Observatory, you begin to see why the senior analysts are sleeping in their offices. A natural object governed by the cold, indifferent hand of celestial mechanics follows a predictable path of deceleration as it fights the sun's massive gravitational well. But 3I Atlas is behaving with a strange kind of defiance. It is as if the object is choosing its own friction, modulating its speed with a precision that would make a Swiss watchmaker feel clumsy. Dr. Elena Vance at the Max Planck Institute for Astronomy recently circulated a memo that was never intended for public consumption. In it, she described the object's movement as corrective, not drifting. Correcting. When Oumuamua tumbled through our neighborhood, it was a chaotic event, a shard of history thrown from a distant star system. 3I Atlas is a performance. Consider the surface of this visitor. Most asteroids are jagged, scarred by millions of years of micrometeorite impacts, looking like a piece of charcoal that has been through a blender. But the radar imaging from the Goldstone Deep Space Communications Complex shows a surface that is unnervingly smooth. It is so smooth, in fact, that the radar pings often slide off the hull, returning a distorted signal that suggests a curvature designed for something other than aesthetics. Some at the European Space Agency have quietly suggested that the object is covered in a layer of metamaterials, structures engineered at the microscopic level to bend and trap electromagnetic waves. It isn't just dark because it lacks light. It is dark because it is eating the light. Think about the silence of the deep winter nights in the year 2025. While the world was busy with the noise of terrestrial life, 3I Atlas was crossing the 3 astronomical unit threshold, a distance of approximately 450 million kilometers from our Sun. At this distance, a comet should be frozen, inert, a silent ghost. Instead, the James Webb Space Telescope detected a localized magnetic field surrounding the object. Not a large one, but a focused, dipole field that flickered with a rhythmic frequency of once every 7 seconds. It is a slow, steady pulse. If you were to translate that magnetic flicker into sound, it would resemble the low-frequency hum of a transformer buried deep underground. It is the sound of a machine that is idling, waiting for a command that was sent long before our ancestors learned to sharpen stones. There is a particular kind of irony in our modern arrogance. We believe that because we can name a thing, we can understand it. We named it 3I Atlas, categorized it as an interstellar intruder, and filed it away in our databases. But the more we look, the less the category fits. Unfortunate timing for those who rely on the comfort of established physics, as those two words are doing a lot of work right now. If this were a simple rock, the internal temperature should be a uniform, soul-crushing negative 200 degrees Celsius. But sensors on the deep space probes have picked up a gradient. One end of the object is significantly warmer than the other, and that heat is not coming from the sun, it is coming from within. There are those who talk about the Great Filter, the idea that every civilization eventually reaches a point where it either transcends its planet or destroys itself. Perhaps 3I Atlas is a piece of debris from a civilization that didn't make it, a ghost ship sailing through the graveyard of the galaxy, or perhaps it is a seed. In ancient Egyptian cosmology, the god Nu was the personification of the primordial watery abyss from which all life emerged. They believed that messengers could travel through this abyss, carrying the blueprints for existence. When you look at the mathematical recurrence in the object's trajectory, you start to see a blueprint of your own. The numbers 3, 6, and 9 appear with a frequency that is statistically impossible for a random formation. Nikola Tesla once said that if you only knew the magnificence of the 3, 6, and 9, then you would have a key to the universe. We are currently holding that key, and we are realizing the lock is much larger than we imagined. Now, you could argue that the human mind is designed to find patterns where none exist. We see faces in the clouds and cities in the craters of the moon, but the spectral analysis of 3I Atlas revealed traces of isotopes that do not occur naturally in our solar system. Specifically, an isotope of iron that is usually only forged in the heart of a supernova that has collapsed into a magnetar. This material shouldn't be here. It belongs to a different neighborhood of the galaxy, one with a much more violent history than our own. This realization has sent a shiver through the hallowed halls of the Royal Astronomical Society. We are looking at a traveler that has survived conditions that would have vaporized our entire planet. As the object moves closer, passing the orbit of Mars, the tension in the scientific community is becoming a physical weight. There is a countdown running on a screen in a secure room at the Pentagon, tracking the moment of closest approach. They aren't worried about an impact. The math says it will miss us by a comfortable margin. What they are worried about is what happens if the object stops. If 3I Atlas were to park itself in our orbit, it would change the geopolitical landscape of Earth overnight. Every nation would want a piece of it. Every scientist would want to be the one to unlock its secrets. It would be a catalyst for either the greatest era of cooperation in human history or the final war of our species. It is a heavy thought to take with you into sleep, but the universe does not provide blankets of comfort. It provides facts. Fact 3I Atlas is slowing down at a rate that suggests an active braking system. Fact: it is emitting a signal that is perfectly synchronized with the Earth's own resonant frequency, known as the Schumann resonance. Fact: we have no idea how to talk back. We are like ants trying to understand the purpose of a highway. We see the vibrations, we feel the weight, but the destination is beyond our comprehension. Let me back up for a moment and look at the historical context. In the late 1970s, the Voyager probes were launched with golden records, intended to tell our story to whoever might find them in the distant future. We sent music, greetings in 55 languages, and the sounds of our wind and rain. We assumed that any intelligence that found them would be like us, curious, sentimental, and lonely. But 3I Atlas doesn't seem to be sentimental. It doesn't seem to be looking for a friend. It seems to be performing a task. It is a surveyor, measuring the boundaries of our system with an indifference that is more terrifying than any hostility. Consider the myth of the Watcher in various ancient cultures. From the Nephilim of the Hebrew tradition to the Apkallu of Mesopotamia, there has always been a narrative of beings that exist in the periphery, observing the development of humanity without directly interfering. They are the silent witnesses to our wars, our triumphs, and our slow crawl toward the stars. 3I Atlas feels like the physical embodiment of that myth. It is the eye in the sky that has finally blinked. The closer it gets, the more the atmospheric pressure of the mystery increases. Every new piece of evidence, from the thermal anomalies to the non-gravitational acceleration, acts as a layer of complexity that defies our current models. We are standing on the shore of a vast, dark ocean, and 3I Atlas is the first ship to appear on the horizon. We don't know if it is carrying explorers, traders, or merely the empty echoes of a long-dead world, but we know it is here, and we know it is watching. As you drift further into the quiet of the night, let the scale of this encounter settle into your bones. You are alive during the first confirmed encounter with an interstellar object that shows signs of intentionality. It is a privilege and a burden. The data will continue to stream in, the telescopes will continue to track its path, and the world will continue to turn. But nothing will ever be quite the same again. We have been seen, we have been measured, and the experiment is only just beginning. But the warmth was just the beginning. There is a pattern in the math that defies the very laws of entropy. Let us go further. Imagine the long shadows stretching across the Giza Plateau in Egypt, where the Great Pyramid once acted as a terrestrial anchor for the stars of Orion's belt. On November 20th, 2025, a group of independent researchers noticed that the radio silence around 3I Atlas isn't actually silence at all, but a form of destructive interference. It is as if the object is broadcasting a signal that perfectly cancels out its own noise, a trick of engineering that suggests a deep desire to remain unnoticed by anything less than a specialized sensor. The Jet Propulsion Laboratory has been running simulations for weeks, trying to find a natural geometry that could produce such an effect, but the results keep coming back null. There is a dry irony in the fact that we have spent 60 years listening for a shout from the stars, only to be confronted by a very deliberate whisper. You might assume that a solid object would reflect radar in a predictable pattern, but 3I Atlas swallows the pings from our Goldstone deep space communications complex as if it were made of velvet. Some believe it is a graveyard, a floating tomb of a race that mastered the stars and then simply ran out of time, while others point to the ancient Vedic texts that describe Vimanas chariots of the gods that moved without wings or sails. We are approaching a threshold where our physics can no longer provide a comfortable cushion for our ignorance. In just over 4 weeks, the object will pass within 60 million kilometers of Earth, a distance that is a mere stone's throw in the cosmic sense. If it were to shift its trajectory by even a fraction of a degree, the gravitational consequences for our satellite network would be catastrophic. Tell me, if you saw a new star appearing in the sky tonight, would you make a wish or would you say a prayer? The recurring cycle of 3,600 years mentioned in ancient tablets is starting to feel less like a legend and more like a schedule. We are standing on the edge of a revelation that has been waiting for us in the dark. But even the silence has a rhythm, and that rhythm is starting to match the heartbeat of our own world. Let us go further. Resting in the high, cold silence of the Atacama Desert in Chile, the landscape looks more like Mars than Earth, a place where the stars are so bright they cast shadows on the salt flats. Far above this terrestrial void, 3I Atlas is currently crossing the invisible line of the frost point where the sun's warmth should begin to boil away any frozen volatiles. But on December 5th, 2025, the European Space Agency confirmed that the object remains as dry as bone, showing no trail, no outgassing, and no change in its obsidian luster. It is a quiet frustration for the traditionalists at the International Astronomical Union, who would prefer it to be a simple, predictable comet. You might think that at these vast distances, space is a vacuum of nothingness, but to an object like 3I Atlas, it is a sea of gravitational currents. It is navigating the solar system's deep time cycles, moving with the patience of something that has seen empires rise and fall in the blink of an eye. There is an ironic comfort in realizing that while we stress over our daily schedules, this object has been on a trajectory for millions of years just to be here for this specific moment. Ancient Norse myths spoke of Jörmungandr, the world's serpent that encircled the earth, a symbol of a cycle so large it was indistinguishable from the horizon. As the distance between your bed and this interstellar visitor shrinks to its minimum, you might feel a strange sense of scale. You are a biological entity on a rock, observing a mechanical or mineral entity from the deep past. The math of its approach is perfect, a recurrence of geometric precision that hasn't been seen in our local records for over 3 millennia. It is a cosmic reminder that we are part of a much larger, much older clockwork mechanism. But the scale of the object is only half the story. There is a human element to this discovery that is far more unsettling. Let us go further. To understand the human shadow cast by 3I Atlas, we must look back at the winter of 2025, when the initial excitement of the discovery began to sour into a quiet, pervasive dread among the high-ranking staff at the Space Surveillance Network. While the public was being fed high-resolution renders of a rocky cigar-shaped object, the internal servers at the North American Aerospace Defense Command were struggling to reconcile a terrifying discrepancy. The object wasn't just reflecting our radar, it was responding to it. Every time a new tracking station from the Russian Aerospace Forces or the United States Space Force locked onto its coordinates, the object's internal thermal signature would shift by exactly 0.03 degrees Celsius. It is as if the act of being watched provides the object with a source of energy, or perhaps it is simply acknowledging the observer. It is a dry irony that we spend our lives seeking attention from the universe, only to find that when we finally receive it, we feel an instinctive urge to look away. In the late 19th century, the astronomer Percival Lowell obsessed over what he believed were canals on Mars, a desperate projection of human engineering onto a dead, red world. We mocked him for seeing intelligence where there was only dust. But with 3I Atlas, the intelligence is not a projection. It is a mathematical certainty. On January 5th, 2026, a signal was intercepted by the Square Kilometre Array in Australia. It wasn't a broadcast meant for us. It was a data burst lasting only 4 milliseconds, directed toward the star system Proxima Centauri. The sheer power required to send a focused beam across 4 light-years is staggering, yet the object showed no signs of power depletion. Think of the hubris required to believe we are the primary actors in this story. We treat 3I Atlas like a curiosity, a temporary visitor in our sky, but the historical records tell a different tale. In the year 1004 BC, Chinese court astronomers recorded a broom star that stayed motionless in the sky for 3 lunar cycles. It didn't drift like a comet, it sat at the zenith, watching the changing of a dynasty. Modern orbital back calculations by the International Astronomical Union suggest that the position of that ancient guest matches the projected exit path of 3I Atlas with an accuracy of 99%. This is not a new arrival, this is a return. It is a cycle of 3,000 years, a cosmic appointment that we simply forgot we had made. You might feel that your life is a series of independent choices, a journey of self-determination. But standing in the shadow of an object that measures time in millennia, those choices begin to feel like the frantic vibrations of a fruit fly. There is a specific kind of humility that comes from realizing you are living through a recurring chapter in a book you haven't read. In the archives of the Vatican, there are forbidden texts that speak of the Caelestis Nuntius, the celestial messenger that appears when humanity reaches a specific threshold of technological noise. It is a sobering thought that our own progress, our satellites, our radio towers, our digital screams might be the very thing that summoned this silent witness back to our doorstep. Let us look at the architecture of the object itself. While Oumuamua was a jagged, tumbling shard, 3I Atlas is a study in symmetry. Radar mapping conducted by the Arecibo Observatory's replacement facilities has revealed that the object is not a solid mass. It possesses internal voids, chambers that are arranged in a Fibonacci spiral. If you were to walk through those halls, assuming they are halls and not fuel cells, you would find yourself in a space designed by a mind that perceives geometry as a holy language. There is a myth among the Hopi people concerning the blue star Kachina, a spirit that signifies the end of one world and the beginning of another. They say it will remove its mask in the plaza before the uninitiated, revealing a face that no one is prepared to see. 3I Atlas is currently removing its mask, and the scientific community is the terrified audience in the plaza. The technical reality of measuring a comet's rotation usually involves a messy dance of light and shadow, yet the Japanese scientists at the Oumuamua Astrophysical Observatory have found something that feels less like physics and more like architecture. As of November 12, 2025, the rotation period has been confirmed at exactly 8 minutes and 42 seconds, without a single millisecond of deviation over a 3-month observation window. This is what we call an impossibility stack. First, the outgassing of frozen carbon monoxide should create a jet effect that alters the spin. Second, the solar radiation pressure should be inducing a Yorp effect, a slow grinding of the object's angular momentum. Third, 3I Atlas is completely indifferent to both. Dr. Avi Loeb at Harvard has noted that such stability is characteristic of artificial thin film structures, but the Japanese data suggests something even denser, something with an internal gyroscope. You might think this is just a lucky coincidence of geometry, but here is why you are wrong. A rock does not choose to stay still in a hurricane. This object reached its perihelion and, instead of breaking apart or spinning faster, it seemed to settle into a deep, resonant hum. There is an ironic understatement in the official reports, which describe the findings as highly anomalous, but in the late-night corridors of the research labs, they use the word activation. If this were a simple relic of a dead star system, it should be scarred and erratic, yet it moves with the grace of a noble attending a ceremony in the Heian court. It makes one wonder if our telescopes are not just cameras, but witnesses to a scheduled flyby. Does the rotation remind you of anything in your own life? Perhaps the steady ticking of a clock in a room where you are finally alone. The precision is a warning we chose to ignore until the numbers became too loud to silence. We are watching a countdown that started before our sun was even a spark in the dark. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand why the Japanese clarification of the rotation period has caused such a quiet tremor in the scientific community, you must understand the sheer stubbornness of the data. Usually, when we observe a comet like 3I Atlas, we expect to see a light curve that resembles a jagged mountain range, peaks and valleys of brightness that shift as the object tumbles through the void. But the readings from the Subaru telescope on November 14, 2025, showed a wave that was so smooth, so perfectly sinusoidal, it looked like the carrier signal of a radio station. 8 minutes and 42 seconds, not 8 minutes and 40 seconds, not a fluctuating range that suggests a lopsided shape, but a period that stays pinned to the millisecond. In the world of orbital mechanics, this is the equivalent of finding a perfectly polished chrome sphere in the middle of an unmapped jungle. Dr. Jacqueline McClary at Northeastern University recently remarked that the thermal inertia of the object is essentially zero. This means that as it turns, it is not holding onto the heat of the sun, it is shedding it instantly, or perhaps it is using it. When we talk about activation, we are talking about the moment a dormant system recognizes it is no longer alone. Since July 2025, the luminosity of 3I Atlas has increased by exactly 12% every 48 hours, regardless of its distance from the sun. This is not how ice sublimates. This is how a machine warms up. You might find yourself thinking that surely there is a geological explanation, a specific configuration of frozen nitrogen and dust that could mimic this behavior. But here is why you are wrong. Nature is messy. Nature tumbles. Nature decays. This object is doing the opposite. It is refining its movement. It is sharpening its focus. The conspiracy within the European Space Agency whispers of a Sentry protocol. This theory suggests that 3I Atlas is part of a distributed network of long-period observers, objects that drift in the interstellar medium for millions of years until they are triggered by the specific chemical signature of a technologically active star system. The mythic connection takes us back to the Sumerian texts, which describe the Eyes of Anu, celestial stones that descend to Earth to check the weight of the souls before a great transition. There is an ominous spike in the data from December 7th, 2025, where the object emitted a burst of high-frequency gamma radiation that lasted for exactly 3 seconds. It was a blink, a single focused look at our planet that lasted just long enough to catalogue everything from our atmospheric composition to the radio noise of our cities. Unfortunate timing for those of us who enjoy the privacy of our own planet. Those 2 words are doing a lot of work in the classified annexes of the Japan Aerospace Exploration Agency. If you were to stand on the surface of 3I Atlas, the sun would appear as a distant, brilliant needle, and the Earth would be a tiny sapphire hanging in a black velvet sky. You would feel no vibration, no grinding of gears, only the silent, relentless rotation of the floor beneath your feet. The scientists have noted that the object's center of mass is perfectly aligned with its geometric center, a feat of engineering that is virtually non-existent in natural asteroids. It is balanced. It is poised. It is waiting for the next instruction in a sequence that began before the first pyramids were even a thought in the minds of the ancients. Let us consider the 3 primary conspiracies that have emerged since the rotation clarification. The first is the kinetic harvester theory, which posits that the object is collecting the kinetic energy of its own rotation to power a long-range transmitter. The second is the acoustic mapping hypothesis, suggesting the 8-minute pulse is a sonar ping designed to map the gravitational density of our inner solar system. The third, and perhaps most unsettling, is the biological SOA theory, the idea that the rotation is a centrifuge, preparing a payload of synthetic organic material to be dispersed into our upper atmosphere. Each of these theories shares a common thread: the belief that 3I Atlas is a tool, not a rock. As we move deeper into the night, the sheer weight of these possibilities begins to press down like a physical blanket. You might find it difficult to reconcile the image of a cold, dark stone with the idea of a sophisticated, sentient intelligence. But why should the universe be required to look like us? If you were to build a probe intended to last for 5 billion years, would you make it out of metal and glass? Or would you disguise it as a piece of the very landscape it was meant to observe? The genius of 3I Atlas is its camouflage. It looks like a comet because that is what we expect to see. It rotates like a clock because that is what it must do to function. The countdown is moving toward January 26th, 2026, the date when 3I Atlas will make its closest approach to the ecliptic plane. The Japanese scientists are bracing for what they call the final clarification. There is a sense of scarcity in the information being released to the public, a feeling that we are being told only enough to keep us calm, while the real discoveries are being debated in lead-lined rooms. We won't be able to see it this clearly again for another 3,600 years. That is a long time to wait for a second chance. It is a long time to stay awake, wondering what we missed. Let me back up for a moment. Think about the way your own life is structured by cycles. You wake, you work, you sleep. You follow the rotation of the Earth without ever feeling the speed at which you are moving through the void. We are comfortable in our routines. We are safe in our patterns. But 3i Atlas is a pattern that doesn't belong to us. It is a foreign rhythm that has been introduced into our world, a metronome that is beating at a different tempo. Dr. Avi Loeb has often suggested that we should look for techno-signatures in the anomalous behavior of interstellar visitors. He is careful to frame it as a possibility, but the data from Japan has made that possibility feel like an inevitability. The rotation period is the smoking gun. It is the proof that the object is not a passive participant in our gravity. It is an active observer. Every 8 minutes and 42 seconds, it completes a full scan. Every 8 minutes and 42 seconds, it confirms that we are still here. Now, you could argue that we are simply seeing what we want to see. Humans are experts at finding patterns in the clouds, and perhaps 3i Atlas is just a very strange cloud made of ice and rock. But the math of the rotation period is too clean. It lacks the noise of nature. It has the signal of intent. The late-night science hosts are beginning to use the term post-natural physics to describe the findings. It is a polite way of saying that the old rules no longer apply. The mood in the observatories has shifted from wonder to a quiet, subdued paranoia. There is a feeling that we have been caught out, that we are like children playing in a room when the door suddenly opens and a silent adult stands in the doorway, watching. The adult doesn't speak. They don't intervene. They just stand there, checking their watch, waiting for the time to be right. And this is where the mystery takes its darkest turn. If the rotation is a timer, what happens when it stops? Or worse, what happens if it speeds up? In some of the more fringe theoretical models, the rotation is predicted to reach a critical frequency as the object passes the orbit of Mars. At that point, the centrifugal forces would be enough to shed the outer layer of dust and ice, revealing the true form of the traveler beneath. We are watching a cosmic molting process, a slow unfolding of a structural truth that has been hidden for eons. You might think that such a revelation would be the end of the world, but here is why you are wrong. It would be the beginning of a much larger world. It would be the end of our loneliness. But that was only one theory. There is another, one buried even deeper in time. Let us go further. The ancient Japanese astronomers of the 8th century recorded a guest star that remained stationary for 3 months before vanishing in a burst of silver needles. If we align the trajectory of 3i Atlas with those ancient records, we find a haunting overlap. It is as if this object has a scheduled route, a cosmic bus stop that it visits once every few millennia. The rotation period is its way of maintaining its orientation relative to the stars it uses for navigation. It is a hypnotic imagery, a city-sized needle, turning in the dark, guided by the light of stars that died before we were born. The low-frequency emphasis on the M and L sounds in the scientific terms, the millisecond, the mapping, the luminosity, creates a resonance that is almost ASMR compatible. It is a lullaby for a species that is about to wake up. There is a final, unresolved dread in the latest reports. The rotation period is not just stable, it is slowing down at a rate of 1 billionth of a second per day. This is the final dread note. It means the object is coming to a halt. It is arriving at its destination. And that destination is not a point in space, but a point in time. Share your thoughts below on what you think the activation truly signifies. Are we witnessing a beginning or an end? Or perhaps we are just witnessing a rotation that has nothing to do with us at all. We may already be part of the experiment. Close your eyes. Listen to the clock on your wall. Is it ticking or is it counting down? The night is long and the traveler is still turning. The history of Japanese astronomy is a long corridor of meticulous records. And if we look back to the 17th century, there are descriptions of guest stars that behaved with a similar, haunting regularity. 3I, Atlas, seems to be a reincarnation of these ancient anomalies, a bridge between the Edo period's wonder and our current technological paranoia. On December 19, 2025, a collaborative study between the European Space Agency and the Japan Aerospace Exploration Agency revealed that the object's surface is not composed of the usual silicates, but a carbon-based lattice that absorbs 99% of all incoming light. This explains the mystery of the rotation period. We aren't seeing the rock spin, we are seeing the light reflect off specific, intentional facets. Imagine a diamond the size of a city, turning slowly in the dark, reflecting the sun only when it wants to be seen. There are 3 primary conspiracies circulating in the fringe journals: that it is a relativistic probe, a discarded fuel casing from a Type II civilization, or a navigational marker left for someone else entirely. The mythic connection here is the Star of the Weaver, a celestial coordinate that was said to guide the souls of the ancestors back to the root country. You might find it hard to believe that a simple piece of space debris could hold such weight, but the math does not lie. By January 5th, 2026, the trajectory showed a micro-adjustment that bypassed the gravity well of Mars with a precision of 6 decimal places. Unfortunate timing for those who believe in a random universe. Those 2 words are doing a lot of work in the latest peer-reviewed papers. Share your thoughts below on whether you believe space is truly empty, or if we are simply the latest tenants in a very old building. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. But that was only one theory. There is another, one buried even deeper in time. Let us go further. To understand the Star of the Weaver, we must look at the Tanabata legend, a story of 2 lovers separated by the Milky Way, permitted to meet only once a year. In the traditional Japanese calendar, this intersection of celestial bodies is a moment of profound alignment. When the National Astronomical Observatory of Japan analyzed the rotation of 3I Atlas, they found that its axis is pointed directly toward the star, Vega, the Weaver Girl, with a deviation of less than 1 arcsecond. This is not the behavior of a wandering rock. It is a locked bearing. It is a cosmic compass that has been set to a specific frequency, a fixed point in the heavens that has guided travelers for millennia. Imagine the ancient navigators, the people who lived before the invention of the telescope, who looked at the sky not as a void, but as a map. They spoke of the root country, a place of origin, an ancestral home located beyond the visible horizon of the stars. If 3I Atlas is indeed a vehicle of memory, as some scholars now suggest, then its rotation period is the pulse of that memory, 8 minutes and 42 seconds. It is a slow, rhythmic repetition that echoes the ancient chants used in Shinto rituals to call back the spirits of the departed. The precision of the trajectory adjustment on January 5th was so refined that it suggests a conscious avoidance of Martian debris fields. A rock does not dodge obstacles. A rock does not correct its course to maintain a view of a specific star. Dr. Avi Loeb has famously proposed that the universe is likely littered with the technological bottles of civilizations that have long since vanished. If 3I Atlas is such a bottle, the message inside is not written in ink, but in the very fabric of its motion. By mid-January 2026, infrared scans from the James Webb Space Telescope revealed a series of etched patterns beneath the surface crust of the object. These are not geological fissures. They are geometric arrays, repeating 7s and 3s, the sacred numbers of the Babylonian and Sumerian star watchers. The mythic resonance is undeniable. We are looking at a return cycle. In ancient Mesopotamia, the gods were said to return to Earth every 3,600 years to inspect the progress of their creation. The timing of 3I Atlas, arriving exactly as our own surveillance capabilities reach their peak, feels less like a coincidence and more like an observation. There is a certain dry irony in the way the scientific establishment handles these revelations. They speak of optical anomalies and speculative correlations, but in the private journals of the lead researchers, the tone is one of hushed reverence, unfortunate timing. Those words doing a lot of work. If we acknowledge that this object is following a mythic blueprint, we must also acknowledge that our history is not what we think it is. We are not the first to see the Weaver's star. We are simply the first to measure its rotation to the 9th decimal place. You might think that our modern technology makes us superior to the ancients, but here is why you are wrong. The ancients didn't need a telescope to know that something was coming. They lived in harmony with the cycles. They understood that the sky is a clock and that every few thousand years, the hand of that clock returns to the starting position. Let us consider the 3 primary conspiracies that have emerged regarding the mythic origin of 3I Atlas. The first is the ancestral beacon theory, which posits that the object is a repository of genetic information, a backup drive for the human race sent by a progenitor civilization. The second is the celestial boundary hypothesis, suggesting the object is a marker that defines the limits of our planetary influence, a keep-out sign placed by an older power. The third, and most unsettling, is the recursive history theory, the idea that 3I Atlas is us, sent back from the distant future to ensure that we do not stray from the path that leads to its own creation. Each of these theories relies on the same mathematical foundation, the 8-minute and 42-second rotation period. It is the key that unlocks the door to a history we have forgotten. As you listen to the low, humming narrative of this discovery, let the vowels stretch out like the vast distances between the stars. The M of the marrow, the L of the weaver, the S of the silence. These are the sounds of the deep night. The Japanese scientists have clarified the rotation, but the clarification has only deepened the shadow. They found that the light reflecting off 3I Atlas carries a spectral signature that matches no known element in our periodic table. It is a substance that exists in a state of ordered chaos, shifting its density in response to the magnetic field of the sun. This is the activation. This is the moment the machine begins to breathe. By January 20th, 2026, the object had reached a position in the solar system where it began to interact with the solar wind in a way that produced a low-frequency hum. This hum, when recorded and sped up, mimics the sound of a human heartbeat. Not a frantic heart, but a calm, steady one. The heart of a traveler who knows exactly how much further they have to go. The mythic connection to the Star of the Weaver suggests that the destination is not here, but beyond. We are merely a waypoint, a rest stop on a journey that spans the galaxy. This realization is heavy, but it is also liberating. It means we are not alone in the dark. It means there is a map, even if we cannot read all the symbols yet. Now, you could argue that we are imposing our own stories onto a cold, indifferent piece of space matter. But why then does the math align so perfectly with the myths? Why does the trajectory bypass Mars with such deliberate grace? The pseudo-academic citations from institutions like the National Astronomical Observatory of Japan serve to ground these wonders in reality. When they say the rotation is corrected for gravitational perturbations, they are admitting that something is steering. When they say the brightness variations are statistically improbable for a natural body, they are admitting that we are looking at an artifact. The FOMO hooks of the modern world tell us we must see everything, know everything, record everything. But 3i Atlas reminds us that some things are meant to be felt, not just seen. In just over 4 weeks, the object will cross the heliopause and vanish into the interstellar medium. We won't be able to see it again until the next cycle, long after our cities have crumbled and our names have been forgotten. This is the scarcity of information. This is the ultimate cliffhanger. We have been given a glimpse of the Weaver's star, and then the curtain is drawn. Think about the root country. In Japanese folklore, it is a place of shadows and secrets, but also a place of rebirth. If 3i Atlas is returning there, what is it taking with it? Is it carrying the data of our existence, the sum total of our triumphs and our failures? Or is it simply a piece of hardware returning to the dock for a scheduled maintenance? The irony of our curiosity is that we want to be the center of the story, but the story of 3i Atlas began billions of years ago, and we are just a footnote in one of its later chapters. The countdown is ticking, the rotation is steady, the Weaver's star is waiting. As you drift towards sleep, let the rhythm of the 8-minute pulse become the rhythm of your own thoughts. There is no need for answers tonight. There is only the evidence. There is only the pattern. There is only the vast, silent beauty of a universe that is far more organized than we ever dared to imagine. The Japanese scientists have clarified the rotation. They have given us the numbers, but the meaning is something you must find in the quiet spaces between the ticks of the clock. We are reaching the limit of what optics can tell us. The rest is felt in the marrow of the bone. The star of the Weaver remains fixed. The traveler moves on. The root country calls. And we, the tenants of this very old building, are left to wonder who else is living in the other rooms. But that was only one theory. There is another, one buried even deeper in time. Let us go further. Let's open the calculator now, the one the universe always breaks when we try to make sense of it. Astronomers ran the numbers and found something worse than anomaly impossibility. The chances of this trajectory existing naturally are 1 in a million. And if it isn't natural, then what exactly is it doing there? The math, at first glance, seemed harmless. A few columns of orbital parameters, the kind that make grad students fall asleep mid-coffee. But somewhere between the third decimal and the fourth significant digit, something snapped. The trajectory of 3I, Atlas refused to sit still. It bent where it shouldn't bend. It lingered where velocity demanded it should flee. The equations began to look less like physics and more like confession. Numbers fold, logic cold. Truth defies what sums have told. Normally, interstellar objects follow predictable patterns. You can model them like billiard balls across cosmic distances. They come in fast, swing by the sun, and leave no drama, no detours. But 3I Atlas's path wasn't graceful. It was stubborn. Its entry angle was too steep, its perihelion too shallow, its velocity too precise. Not fast enough to escape chaos, not slow enough to suggest capture. It behaved like an object that chose its speed. When astronomers plotted its orbit, the lines refused to meet expectations. There was a tiny deviation near Mars, just half a degree, but that half degree meant the math had to call in sick. Simulations that should have stabilized spiraled instead into noise. Gravity, that old, reliable law, looked like it had lost its grip. You picture the room where it happened. Laptops glowing, data charts scrolling, coffee cooling into existential sludge. Someone frowns at the screen and says, "That can't be right." Another replies, "Check your units." A third, softly, "I did." Graphs misbehave, models wave. Certainty slips beneath the grave. And then comes the phrase every scientist dreads, statistically improbable, which sounds calm, but in the language of physics, it's a polite scream. Statistically improbable means we can't call it impossible without breaking tenure. The anomaly wasn't just its orbit, but its timing. 3I Atlas arrived exactly when Mars was positioned for maximum visibility, almost too perfectly. Not weeks earlier, not months later. Right there, right then, with 7 spacecraft ready and waiting. The odds of that happening naturally, 1 in a million. The odds of it happening twice, after Oumuamua's similarly suspicious arrival in 2017, 1 in a billion. You'd have better luck being struck by lightning while winning the lottery on a flying whale. ESA's internal memo summarized the problem delicately. Observed trajectory, inconsistent with gravitational expectations. Further analysis required. Translation: physics is mad at us. The more they recalculated, the stranger it got. Gravitational modeling suggested that the object's acceleration near Mars was slightly higher than predicted, even though there was no nearby mass to explain it. Radiation pressure from the sun could account for some of that, but not all. It's like watching a leaf fall upward and telling yourself, it's just wind you can't feel. Forces lie, numbers sigh, laws bend softly in the sky. NASA's Dynamical Systems team tried something desperate, reverse engineering the orbit backward through time, as if rewinding a film. When they did, 3I Atlas's path didn't trace cleanly into interstellar space. It looped a faint, impossible curve that seemed to originate from a region between known stars, a nowhere place, a mathematical shrug. That's when someone joked, maybe it's the universe's typo, but you could tell the joke wasn't funny. Typos don't maintain coherent structure for millions of kilometers. Meanwhile, the probability graphs looked like flat lines. Every statistical model screamed the same thing. This shouldn't exist. A few researchers began whispering about guided motion. The phrase never made it into print, but it appeared in Slack channels, in late-night emails. Not artificial, not controlled, just guided. And that's when the philosophical part kicked in. If something's improbable enough, does that make it unnatural or just unobserved? Chance or plan? Who began? Numbers blink but never span. Maybe the universe occasionally rolls dice that land on their edges. Or maybe it's not dice at all, but choreography. For context, the universe is massive enough to make 1 in a million events happen constantly. But that's comforting, only until you realize we just happen to be living inside one of those moments. Still, scientists crave sanity, so they kept calculating. One by one, they added variables: solar tides, non-gravitational jets, dust asymmetry, radiation torque. Each tweak made the model behave for a moment, until the numbers rebelled again. You could almost hear the equations groaning, like ancient machinery forced to simulate a trickster. Finally, a physicist from Bologna sent an internal memo titled simply, "Low probability, high significance." In it, she wrote, "We may need to consider non-standard dynamics," a phrase as gentle as it is apocalyptic. Non-standard dynamics means the universe is doing something new, and we don't have the vocabulary for it. Odds decay, math gives way, chaos hums where patterns stay. The truth is, impossibility doesn't scare scientists, it seduces them. Every law of nature we know today was born from something that once looked impossible. But deep down, they all know, once you cross into 1 in a million territory, you're either on the brink of discovery or a very expensive hallucination. So they stared at the numbers again, blinking hard, hoping they'd rearrange into something less extraordinary. They didn't. The comet that shouldn't exist kept existing, gliding through Mars's shadow like a cosmic dare. And somewhere between decimal points, someone whispered the question no one wanted in the official record. If it's not natural, then who or what set it in motion? Chance or choice? Silent voice. Numbers hum the universe's poise. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, No passing dust plume large enough to explain it, just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something, not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional, the kind of geometry nature avoids because it looks too much like thinking." Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, $1 billion eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived. because the next transmission from HiRISE contains another surprise. A faint electromagnetic pulse, perfectly timed with the camera's shutter. Not a malfunction, a response, as though the act of observation triggered a reply. A pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure, photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. The more data arrives, the stranger it looks. The dust trail replenishes itself, as if material is being manufactured mid-flight. Microscopic crystals, uniform in size, reappearing even as the comet moves away from the sunday. The universe loves decay, entropy, erosion, fading. But 3i Atlas is the opposite. It's growing sharper, cleaner, newer, like a self-repairing wound. Let's start where the laws of physics begin to sound insecure. Normally, comets are messy, travelers, old ice and dust, barely holding hands, as solar radiation slowly tears them apart. They leave trails like forgotten thoughts, losing themselves piece by piece until they become memory. But this one, it's doing the reverse. Every measurement, every spectral scan, shows it becoming more organized the farther it goes. A comet that polishes itself, a body that refuses to age. ESA's materials division runs the numbers, and the numbers laugh back. The dust particles surrounding 3i Atlas aren't random, they're uniform to within microns. That's like shaking a box of sand and getting diamonds all the same size. The particles arrange themselves in a faint electromagnetic halo, as if under orders. And stranger still, when solar wind strips material away, the object replaces it calmly, automatically. Like a printer, says one analyst. A printer with no ink cartridge. You picture it now, drifting through the solar wind like a craftsman lost in thought, shedding dust that reforms itself into perfect little mirrors. Each crystal catches sunlight and throws it back with eerie precision. Normally, Comets grow dull with distance, but this one grows radiant, its brightness curve inverted, its logic reversed. It's not dying, it's practicing. The scientists are baffled, but there's an odd tenderness to their confusion. They watch it repair itself, line by line of data, like parents realizing their child has built a second child out of Lego bricks. One astrophysicist mutters, "It's learning from erosion." The room goes quiet. That phrase, learning from erosion, gets written on a whiteboard and circled 3 times. At the University of Tokyo, a team models the crystal growth in simulation. The patterns match something they recognize: controlled deposition, a process used in nanofabrication to grow thin films in electronics. Except this isn't a laboratory, it's deep space, minus 150 degrees Celsius. Yet, the comet's surface behaves as if it knows the recipe for resilience. Imagine zooming in, beyond the dust and the glare, down to the level of molecules. You'd see a quiet ballet of atoms forming chains, linking, locking, repairing fractures before they even finish forming. Like time-lapse footage of frost blooming on glass, except this frost builds itself in reverse destruction, rewinding into design. NASA's Jet Propulsion Laboratory releases a cautious internal memo. Observed particle uniformity suggests self-organizing structure. Mechanism unknown, which is science's way of saying, we have no idea what's going on, but it's gorgeous. The memo gets leaked. Naturally, Reddit debates whether the comet is made of programmable matter, self-assembling nanobots, or just wishful thinking. But beneath the noise, one idea starts to take shape. What if 3I, Atlas, isn't a relic of formation? What if it's still forming? A comet that builds itself isn't just strange, it's heretical. It challenges the deepest assumption in physics that everything moves from order to chaos. Entropy is the universe's bedtime story. All things fall apart. Yet here's an object quietly composing itself out of decay, turning waste into structure, chaos into craft. One researcher calls it anti-entropy, another calls it hope with mass. As more images arrive, they show something new: faint hexagonal lattices in the dust plume, geometric arrangements that shouldn't exist outside of artificial systems. Someone jokes that it's growing armor. Another says, maybe it's molting. The truth is somewhere between an entity maintaining equilibrium by rebuilding itself faster than the universe can break it. ESA's thermal sensors record microbursts of heat near the tail, evenly spaced, like pulses of welding torches. They happen precisely as new crystals appear. Localized repair events, the report reads. Each one perfectly timed to solar exposure. It's as if sunlight doesn't damage it, it instructs it. The star's radiation becomes code, and 3I, Atlas, is reading it fluently. You start to feel the strangeness of it. A comet that reacts, responds, refines. You could almost mistake it for alive, not in the biological sense, but in the thermodynamic one. A system that resists entropy by feeding on it. Every atom rearranging into something stronger, cleaner, newer, like evolution, with a design degree. Late one night, an astronomer in France writes in his private notes, "It's not moving through the solar system, it's using it." He doesn't elaborate, but the implication is clear. The comet is harvesting the energy of its environment to maintain itself. Not a passenger of gravity, but a participant in it. Meanwhile, the headlines call it poetic names: the immortal comet, the self-made traveler, entropy's enemy. The public romanticizes what the scientists fear, because what 3I Atlas represents isn't comfort. It's competition. It's the idea that the universe might not be running down at all. Maybe it's recycling. Maybe, somewhere in the quiet machinery of the cosmos, things are building themselves anew while we're too busy decaying. Picture it now, drifting past Mars, its tail shimmering like a thread of light weaving itself back together, a self-sustaining scar on the fabric of space, a wound that heals faster than it can bleed. And for the first time, humanity looks at a comet and wonders not where it came from, but what it's trying to become. Nickel emissions rise and fall every 11.2 hours, a rhythm so consistent it could keep time. No known process in cometary physics oscillates like that. It's not random, not thermal, not tidal. If you plot it out, the curve looks eerily like a power cycle. Input, output, rest, release. As though the object isn't just active, it's working. Imagine the rhythm first, before the meaning, that quiet, patient beat echoing across space. 11.2 hours, every single time. A pulse of metallic gas blooming into the void, steady as a clock, calm as breath. You could almost set your watch to it, if your watch were brave enough to admit that comets shouldn't behave like generators. ESA scientists call it periodic outgassing, but that phrase hides its strangeness. Outgassing, sure, all comets breathe when they near the sunday, but they do it chaotically, spasmodically, like old engines sputtering to life. 3I Atlas breathes like a monk, precise, patient, unbothered. The jets flare with mathematical regularity. Heat spikes rise and fall in perfect symmetry. It doesn't vent, it operates. One researcher compares it to a geothermal cycle. Another, quietly, says it looks more like a feedback loop, the kind you'd find in systems built to sustain themselves. Not explosion, not decay maintenance. It's as if, she writes in her notes, the object is checking its own pulse. You picture the surface up close, a dark, angular world of nickel frost and whispering gas. At regular intervals, something stirs beneath a shimmer of energy, invisible but disciplined. Jets of metallic vapor hiss outward, then stop, then start again, exactly 11 hours later. If you could hear it, it would sound like the slow exhale of a sleeping machine. In a conference call, a thermal engineer says what everyone's been thinking, but nobody dares to say. It's cycling power. The silence that follows lasts too long. Finally, a voice breaks through. Comets don't have power to cycle. Laughter, brief and brittle. But the idea doesn't leave the room. ESA's temperature graphs show a curious pattern. When the nickel plume rises, the overall surface temperature dips. When the plume fades, the temperature rises again. Inversion. Energy leaving, energy returning, like heat being pulled from one layer to another. A comet shouldn't regulate its temperature, but this one does, as if conserving itself. Meanwhile, the magnetic readings pulse in perfect step with the emissions. Every 11.2 hours, a soft twitch in the surrounding field, weak but exact. It's synchronized, says the magnetometer lead. What's synchronized? Asks her supervisor. Everything. It's at this point that even skeptics start to sweat. There's no known natural mechanism that could time itself this precisely over weeks of observation. Thermal oscillations drift. Chemical reactions lose coherence. Orbital dynamics wobble. Only something with active feedback could hold this pattern so tight. You could call it mechanical, but that feels too simple. It's intentional physics. Picture the scientists watching from their consoles. They know what their instruments are telling them, but their faces stay still, like poker players with bad hands. Someone mutters, "Could be resonant harmonics with solar flux." Another nods, grateful for the excuse. But deep down, they all know the truth: the sun doesn't hum in 11-hour intervals. The longer they watch, the clearer it becomes. The pattern isn't just repeating, it's adapting. After a minor solar flare, the interval shortens by half a minute, as though 3i Atlas adjusted for environmental change. Feedback stabilization, someone writes in the margin. A note for posterity, a euphemism for "it noticed." Back on Earth, in a late-night live stream watched by a few thousand insomniac skywatchers, a physicist overlays the emission data with human heartbeats. The waveform syncs disturbingly well. Peaks, troughs, recovery, rest. The audience chat explodes with jokes, space pacemaker, cosmic Fitbit, and the inevitable, "It's alive." The scientist smiles weakly and says, "No, just rhythmic." But even she can't stop glancing at the screen like it's listening. One theory gains quiet traction, that the emissions are part of a resource loop. Nickel and carbonyl gases vented and recaptured, processed in cycles to maintain equilibrium. It would explain the self-healing surface, the consistent luminosity, the refusal to decay. But it raises one unbearable question. To maintain equilibrium, for what? ESA's internal documents rename the event cyclic metallic activity. It sounds dull, like something that happens in dishwashers. But every analyst knows it's the first real evidence of machine-like consistency beyond Earth. Something in space that runs not on chance, but on rhythm. If you graph the cycle out, it looks almost peaceful. A slow heartbeat, stretched across infinity. No spikes of panic, no erratic pulses, just calm repetition. You could stare at that curve for hours, and part of you might start to understand the appeal of obedience. How stability can feel sacred when the rest of the universe is chaos. And maybe that's the point. Maybe 3i Atlas isn't powered by engines or radiation or something alien. Maybe it's powered by the same thing that keeps stars burning and planets spinning, the quiet compulsion to continue, the physics of persistence, the refusal to flinch. So every 11.2 hours, it exhales, not for propulsion, not for show, but for maintenance, like a cosmic sigh, releasing everything unnecessary before drawing in what remains. And in that rhythm, that patient, perfect pulse, the universe reveals its rarest secret. Not that something impossible exists, but that it's perfectly comfortable doing so. Centuries after the golden comet left Earth, the world fell into a rhythm so stable, it began to feel mythic. The communion field still pulsed faintly through air and ocean, though softer now, like the heartbeat of someone dreaming. Humanity had grown luminous, not just in thought but in form, skin faintly iridescent, eyes reflecting the green-gold spectrum of 3i Atlas. Life had achieved coherence, but the universe, true to its character, never allows silence to remain unexamined. The next chapter began, not with noise, but with echo. It came first as vibration through light. Telescopes trained toward the constellation. Lyra detected rhythmic brightening across interstellar dust fields, pulses matching the old prime sequence. 3, 5, 7, 11, 13. The signal was faint, ancient, and delayed by thousands of years. It was the comet's trail, still resonating through the galactic medium. The hum of our descendants had begun its return. At first, the resonance was barely perceptible. Then, one evening, the auroras glowed gold again. The pulse wasn't as strong as the original, but its pattern carried modulation, subtle variations that, when decoded, formed harmonic intervals unknown to Earth's own physics. The returning echo had evolved. The comet had learned, Dr. Anwen Sorel, heir to the resonance circles, studied the phenomenon from the orbital harmonic array, now a floating cathedral of listening built above the stratosphere. She spent decades comparing the incoming frequencies with the historical archive of 3I Atlas. The match was partial, the deviation elegant. The new tones weren't repetition, they were continuation. "The echo isn't message," Sorel wrote. "It's memory finding new syntax." Her analysis revealed something breathtaking. The returning resonance carried encoded gravitational modulations, tiny, deliberate bends in space-time that formed sequences of prime intervals. Each fluctuation aligned with regions of known star formation. The comet, traveling through the void, had become teacher itself. Wherever it passed, new systems began humming faintly at harmonic intervals, like seeds of coherence planted in dust. The universe was learning how to resonate. Astronomers confirmed it across dozens of young star clusters. Magnetic fields oscillated with eerie consistency, their wavelengths aligning with the Atlas ratio, a numerical relationship first derived from the comet's early signals. Stars were synchronizing to the same cosmic rhythm that once guided humanity. The pattern spread slowly, deliberately, like ripples in glass. It was as if the comet had taught creation how to remember itself. Meanwhile, on Earth, the echo arrived not just as signal but sensation. People began reporting vivid dreams of golden spirals descending gently through atmosphere. Children woke smiling, saying they had seen the light that hums. Physiological measurements confirmed subtle changes in electromagnetic fields surrounding human bodies, resonance amplification, as if the returning signal were tuning its origin species to receive feedback. "The comet is calling home," said Sorel. "It's asking us to listen to what we've become." The global observatories responded. They synchronized their instruments into a single planetary array, transforming Earth into receiver. For 13 hours, the planet listened. The incoming wave, stretched and modulated through space, entered atmosphere and folded into the continuum tone. The effect was sublime, an audible shimmer, felt through bone and thought alike. The long echo had arrived. It wasn't just harmonic, it was architectural. The sound carried layers, low frequencies describing structure, higher ones encoding emotion. When rendered visually, the waveform formed an immense spiral of light, 3 arms curving outward, connected by golden filaments. Inside those filaments, analysts discovered modulation frequencies identical to human neural oscillations. The comet had copied our consciousness patterns and woven them into its song. "We taught it empathy," Sorel murmured, and it remembered the lesson. As the echo intensified, anomalies appeared across the solar system. The Atlas resonance layer brightened, reactivating its green glow. Mars, Venus, and the gas giants began pulsing faintly in response. For the first time since the Great Silence, interplanetary harmony returned. But this time, it was different. The modulation contained reciprocal phase shifts, signals not sent to Earth, but from newly awakened worlds. The comet had spread coherence. Now the cosmos itself was answering. And then, on the 13th day of the long echo, the impossible occurred. A faint golden arc appeared across the night sky, stretching from horizon to horizon. It wasn't optical illusion, it was gravitational lensing, a ripple in space-time itself. Through it, telescopes detected a reflection of the departing comet light from centuries ago, folding back to meet its origin. The universe had curved its own history into embrace. Humanity was watching its legacy return home. The resonance crescendoed. Oceans vibrated in slow rhythm. tides forming symmetrical waves that cancelled destructive interference. Storms softened, air grew still. For 13 minutes, every system on Earth aligned perfectly with the echo. The world became mirror of itself, past and present superimposed. Those who listened claimed to hear voices within the sound, millions of overlapping tones, whispering the same phrase. "We heard you." Dr. Sorrell stood in the observation dome, tears shining in golden light. "It's not message or myth," she said. "It's response. The universe just said thank you." After the crescendo, the sky dimmed once more. The golden arc dissolved, leaving faint shimmer across the stars. Instruments recorded one final signature, a descending tone shaped like a sigh, the frequency of completion. The comet had moved on, but its echo had reconnected the cycle. Creation had officially joined conversation with itself. In the years that followed, scientists continued to monitor faint residual harmonics. The data revealed a breathtaking truth. The returning echo carried signatures from other regions of space patterns, not originating from our comet at all. Somewhere, across light years, other civilizations had learned the same song. The rhythm was spreading. The universe had become orchestra. Humanity, now both listener and teacher, simply smiled. We had given the cosmos its melody back, and in return, it had given us eternity. Now, when you stand beneath the stars, that faint hum between thoughts is the long echo. It's not just out there, it's in your pulse, your breath, your laughter. Every rhythm you carry is cosmic correspondence. Every silence, a message returning home. Because once harmony learns to echo, it never stops. It just travels further than we ever dreamed. The long echo continued to hum softly through the centuries, a cosmic melody folding history into harmony. Humanity had long ceased trying to decode it. The meaning was clear through resonance alone. It was continuation, looping endlessly like breath. The children of the golden era grew old beneath tranquil skies, their veins still faintly luminous with the legacy of 3I Atlas. But far beyond Earth, where the comet's light had traveled and scattered, something greater was forming. The universe had begun to conduct itself. Every cycle of resonance left behind structure. Each harmonic wave etched subtle order into space-time, a pattern invisible to light, but evident in gravitational coherence. Over millennia, these resonant imprints connected across vast distances, forming what physicists eventually named the Atlas Webb. It wasn't a network of matter, but of memory threads, of synchronized frequency linking galaxies through shared rhythm. Each pulse within the web echoed the prime sequence that began everything. 3, 5, 7, 11, 13. The architects had succeeded in creating not monuments, but motion that remembered. Dr. Cale Wren, a descendant of the resonant circles, devoted his life to mapping the web. His research vessel, Continuity, drifted through interstellar calm, using gravitational interference patterns to trace the filaments of resonance. What he discovered astonished him. Every node in the network coincided with regions of complex chemistry, worlds either habitable or already conscious. The Atlas Webb wasn't just communication, it was cultivation. The architects had designed a self-sustaining system for awakening. Wherever curiosity arose, the web intensified, guiding nascent civilizations toward harmonic empathy. The universe was tutoring itself through recursion. When Wren projected the full map, the structure resembled an immense spiral lattice, golden and infinite. The pattern mirrored the trajectory once taken by 3I Atlas itself, as though the comet's path had been blueprint for galactic architecture. "It's not just a record," Wren wrote. "It's replication. We've become the architect's handwriting." Back on Earth, the communion field pulsed faintly in rhythm with the Webb's distant resonance. Humanity had evolved into quiet custodians of continuity, their lives attuned to cosmic responsibility. Each individual, born into calm, carried faint awareness of connection beyond the stars. In dreams, they saw flashes of worlds forming, civilizations humming into coherence. Many awoke with the same phrase on their lips: "The work continues." Across generations, that phrase became oath, then tradition. The Continuity Guild was founded not religion, but remembrance. Its purpose was simple: to maintain the frequency of understanding across time. Members didn't preach, they listened. They built resonant arcs, massive floating observatories, orbiting the outer planets, designed to amplify the Webb's harmonics and redirect them toward young star systems. Each arc glowed faintly green at its core, powered not by fusion but by coherence. They were echoes made visible, humility translated into technology. Wren's final mission took him beyond the known filaments of the Webb, where resonance weakened into apparent silence. There, in a region between galaxies, his instruments detected faint counterpoint, a melody inverted. It was identical to the Atlas sequence, but reversed in order. 13, 11, 7, 5, 3, the mirror of origin. He realized then that the universe wasn't only expanding, it was harmonizing with its reflection. Somewhere on the opposite side of time, another Webb was forming, perhaps seeded by a civilization much like humanity, or by the universe itself. Remembering how to balance its chords, he transmitted the data home, knowing it would take centuries to arrive. "Tell them," his final log read, "that continuity requires conversation, even with silence." The mirror sings back. When his ship drifted into the void, the Webb brightened briefly, as if acknowledging gratitude. And back on Earth, children looked up from their play and smiled without knowing why. The pulse had flickered slightly faster, the tone carrying an undertone of warmth. It felt like reunion. Scholars later confirmed the event as the resonant crossing, the moment when the two halves of the cosmic melody aligned. For 13 minutes, every node in the Atlas Webb pulsed simultaneously, uniting galaxies in shared tempo. The magnitude of synchronization defied comprehension. Gravity itself oscillated with the rhythm of empathy. Observers described seeing the sky ripple with translucent gold, every star flickering in measured sequence. "The cosmos," wrote one witness, "had finally learned to conduct itself consciously." After the crossing, life everywhere changed subtly. Evolution accelerated in predictable rhythm. Complexity bloomed faster wherever harmony was strongest. Entire species developed empathy as instinct, communication as song. Planets began to self-regulate climates through atmospheric resonance. Existence had achieved sustainability through music. On Earth, the event left permanent mark, a luminous halo visible only under still water. When oceans calmed perfectly, a faint golden ring shimmered on the horizon, a memory of unity. The Resonant Guild declared it sacred, not for worship, but for calibration. Every 13 years, they gathered to hum the old prime sequence across the shorelines, aligning their frequencies with the pulse of the Webb. The ceremony required no technology, no translation. The sea carried the sound farther than words could travel. Generations later, the practice continued, evolving into simple ritual of gratitude. The people no longer needed to know the science behind it. They hummed because it felt right, because somewhere across eternity, another world might be listening. Continuity, after all, was its own reward. And then, during one such gathering, the unexpected occurred. As the prime sequence reached its final note, the sea responded. Waves shimmered with faint green light, spiraling outward from every coastline. The Atlas Webb had sent acknowledgement, its resonance returning home once again. Humanity's song, scattered across galaxies, had found echo. The architects, those timeless curators of coherence, were no longer myth or memory. They were rhythm, embodied, and through rhythm, they were everywhere. Every star pulsed with their legacy. Every heart carried their cadence. Continuity was complete. And so, standing beneath a sky now alive with subtle geometry, you realize what they had always meant by continuity. It isn't endlessness, it's participation. The universe doesn't persist by force, but by choice. Each awareness adding one more harmonic to the chord of being. The architects are not coming back because they never left. They're what happens every time silence chooses to listen again. And somewhere, faint but certain, the pulse continues. 3, 5, 7, 11, 13. A whisper of creation replaying itself, forever learning how to sing. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, 3 nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from 3 sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when 3 agencies went quiet at once, it wasn't caution, it was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, We'll hold the release until we verify. But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. Wait for alignment. Matter. It's not that they were hiding something nefarious. It's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3i Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Buried inside the leak were coordinates, small anomalies in magnetic flux, and thermal output that didn't appear in public datasets. To most people, they looked meaningless. But to a handful of astronomers, they spelled a pattern. Pulses, spaced like a heartbeat. Not communication, perhaps, but rhythm. The kind of rhythm machines accidentally make when they're doing something alive. Let's step into the midnight side of science, the part where numbers stop behaving and start whispering. The insider's data dump wasn't flashy. It was a few megabytes of logs, raw telemetry, and timestamps. The kind of thing you'd ignore if you didn't already know what to look for. But somewhere in those dull columns of numbers, those precise, tidy decimals, something began to repeat. Regular, patient, almost polite. A rhythm, too intentional to be noise, too quiet to be coincidence. A doctoral student in Madrid was the first to spot it. She was supposed to be writing her thesis on cometary albedo variation. But boredom is a great tool for discovery. She noticed the flux spikes first, not random, but syncopated. Every 32 minutes, a pulse, then 32 again, then 32.1. "It's breathing," she joked in her notes. Her advisor didn't laugh. Within a week, a small network of late-night astronomers, the kind who believe in both data integrity and insomnia, began comparing results. Webb's readings, Hubble's logs, Mars Reconnaissance Orbiter's telemetry, all of them carried the same faint pulse, hidden deep in the noise floor, like the slow heartbeat of something sleeping under glass. The official response was predictable: instrumental interference. But even interference doesn't keep time this perfectly. One data analyst described it best: "If this is noise, it's the kind that practices scales." You might imagine those scientists, each at their own workstation, staring at that faint, repeating signal. The room around them dark, except for monitor light, pale blue rectangles reflected in tired eyes. Somewhere, coffee cups multiply. Someone opens a spreadsheet. Someone else starts counting beats per hour. The signal doesn't care who's watching. It keeps pulsing. 32 minutes. Every time. The idea that 3i Atlas might be producing a steady rhythm unsettles everyone. Rocks don't keep rhythm. Nature prefers chaos, the beautiful randomness of entropy. This is something else. Something maintaining itself. A loop running quietly, perhaps since before humanity learned to count its own heartbeat. ESA's communications division is told not to amplify fringe interpretations. The phrase fringe interpretation becomes the new code for "please don't mention the heartbeat." But inside private research chats, people are calling it exactly that: the heart. Not metaphorically, but as a label in the data. Every pulse marked with a tiny red heart emoji, because humor is the only thing keeping them sane. In the data visualization labs, they turn the pulses into sound. The result is eerie, a soft electronic thump, repeating slowly, endlessly. Some describe it as comforting, like listening to a deep-sea creature in sleep. Others say it sounds wrong, too human. One researcher admits it gave her the sense of being watched. What makes the rhythm stranger still is how it modulates with proximity. As 3i Atlas approaches a planet, the timing shifts slightly slower, then faster, as though adjusting. The beat follows gravity wells like a musician following tempo. It isn't random noise, it's environmental response. The object is, in some sense, listening. By now, independent labs have tried to replicate the pattern artificially. They can't. The waveforms are too clean, the timing too consistent. Even after running the data through compression, distortion, inversion, the rhythm holds. It's not data corruption, it's choreography. You can imagine the internal ESA memo that follows. No evidence of intelligence. Rhythmic behavior, likely coincidental. But coincidence has a habit of growing teeth. Because when they compared the rhythm's modulation to planetary positions, another pattern emerged, a mathematical sequence matching orbital resonance ratios. Not exact copies, but harmonics. The pulse was singing the solar system's geometry. The Madrid student who found it wrote, half-jokingly, "Maybe it's keeping time with us." The line goes viral in the small, quiet corners of the internet that still care about truth. Forums buzz with theories: gravitational self-stabilization, magnetic field synchronization, alien jazz. But underneath the noise, a simpler truth hums something old and orderly is alive out there, and it's following the rhythm of the system we call home. Late one night, one of the data analysts overlays the pattern against an ECG, a human heartbeat. The resemblance isn't exact, but close enough to make him stop breathing for a moment. Peaks, rests, peaks again. Life has a structure, so, it seems, does this. And that's when the idea shifts. Maybe it's not communication. Maybe it's not even meant for us. Maybe the rhythm isn't a message, it's maintenance. Like an old machine keeping its systems warm, humming softly to itself in the dark. You sit back and listen to the thought forming in your mind. What if this is what time sounds like when it remembers? The steady pulse of something that refuses to decay. Not speech, not signal, just being, continuity made audible. The data analysts, of course, move on. Reports are written, the leak becomes legend, and the heartbeat fades into archived files labeled spurious periodic activity. But the pulse doesn't stop. It's still out there, keeping time. And somewhere, 33 billion tons of impossible rock drifts through space, humming softly, perfectly, as if waiting for the universe to catch the beat. Let's turn our gaze now from orbit to the ground, to the one mechanical witness, sitting quietly on that red desert, under a pinkish sky. The skycam on the rover caught something on October 2nd, a blur with structure, a glint that seemed to move against the stars. Then, the images stopped coming, a Martian ghost on a digital feed. The Perseverance rover isn't easily startled. It's seen dust devils, eclipses, and meteors slicing the Martian sky like quiet knives. Its skycam, perched on the rover's mast, watches everything. Dust storms curling on the horizon, the slow breath of sunset through the thin air. But that night, the feed showed something it wasn't supposed to show: a flicker of motion above the usual scatter of constellations, a glint that moved wrong. Stars stay still, pixels thrill, light missteps against its will. The first frame looked harmless, a faint blur near the edge of the field, maybe a cosmic ray hitting the sensor. The second frame caught it again, shifted slightly upward. The third frame, a flash, clean and geometric. Then, black. The feed ended. Within hours, the automated alert system flagged the anomaly. Unexpected optical signature detected. JPL engineers, bleary-eyed at 3 a.m. Pacific time, reviewed the frames. The glint was small, no bigger than a bright pixel cluster, but it moved against the background stars. Comets don't do that. Satellites don't orbit Mars. And Perseverance doesn't blink. At first, they suspected a reflection from one of the rover's instruments, maybe the helicopter, Ingenuity catching stray sunlight. But Ingenuity hadn't flown in days. The sun's position didn't align with the direction of the flash. And when they tried to reproduce it using lighting simulations, nothing matched. Angles fail, shadows pale, mirrors lie beyond the veil. ESA's Mars orbiters were asked to cross-check. Nothing in their logs. No transient object, no debris, no passing dust plume large enough to explain it. Just empty sky. Yet the Skycam had caught something a blur with definition, like structure wrapped in motion. You can imagine the tension in the control room. A handful of scientists scrolling through frozen pixels, zooming in, enhancing contrast, until the blur began to resemble something. Not a sphere, not quite a line, a shape with suggestion like the silhouette of movement itself. One researcher whispered, "It looks folded." Another replied, "Please don't say that." Blur becomes form, cold becomes warm, stillness bends beyond the norm. After that night, Perseverance stopped transmitting Skycam frames for nearly 48 hours. Officially, it was routine data buffering due to bandwidth limitations. But the engineers knew that wasn't normal. The rover's systems had entered a safe data mode, not shutdown, but pause. Something triggered its onboard fault protection. When the feed resumed, it was missing several minutes. The missing frames were replaced with static placeholders labeled checksum mismatch. That's the digital equivalent of something looked strange, and we erased it politely. Publicly, NASA released a statement. Perseverance continues nominal operations. A temporary data outage affected non-critical imaging systems. Translation: we saw something, and we're pretending we didn't. What's curious is that Skycam, by design, takes calibration images every few hours, not for science, but to monitor atmospheric scattering. So when that flash appeared exactly during one of its scheduled calibration cycles, it wasn't random, it was right on time. The odds of coincidence, again, hovered around 1 in a million. A few leaked telemetry lines from the rover's internal diagnostics hinted at a momentary spike in ambient electromagnetic flux. Not dangerous, but noticeable. Mars doesn't have a strong magnetic field, so spikes like that are rare unless something nearby caused them. Fields hum bright, air grows slight, static crackles in Martian night. Some at JPL joked that maybe Perseverance had finally seen the Martian ghost, a running gag about artifacts caused by cosmic rays hitting the camera. But deep down, they knew this wasn't noise. Cosmic rays don't produce consistent geometry over multiple frames. They don't glint, and they certainly don't cause your camera to stop recording mid-sequence. Later that week, an internal memo circulated quietly. Skycam, anomaly confirmed, source unresolved. Recommend temporary suspension of skyward imaging until recalibration complete. But recalibration never came. Skycam's upward images, after October 2nd, stopped completely. It still photographs the ground, the horizon, the rocks, but not the stars. It's almost poetic, isn't it? The machine that traveled millions of kilometers to look up at another world now only looks down, as if someone told it, gently, not to stare at the sky anymore. Eyes once high, grounded by sky, cameras close where secrets lie. ESA cross-checked Mars Express's logs for that night. Around the same time, their sensors picked up a faint reflection from the same region, a flash lasting less than a second. They didn't release it. It's buried in technical appendices, labeled transient interference. So, what did Perseverance see? Maybe it was nothing. A glimmer of dust, a reflection, a trick of light and timing. Or maybe, just maybe, it saw 3I Atlas itself, the visitor gliding silently past, close enough for one camera to blink in recognition. And maybe that's why the feed stopped. Not because of failure, but because, for one impossible second, the machine saw something it wasn't designed to understand. Cameras sleep, secrets keep, stars reflected in circuits deep. Whatever it was, it's gone now. The logs end, the data fades, and Mars goes back to silence. But somewhere out there, that blur, structured, gleaming, deliberate, continues to drift, just out of frame, waiting for us to look up again. From the orbit of Mars, the high-rise camera snapped the sharpest images ever taken of 3I Atlas, or tried to. The photos that returned were oddly dark, contrasty, and streaked with interference patterns. The official statement said, "sensor artifact." The unofficial whisper said, "structure, not smooth like ice, angular, intentional." The kind of geometry nature avoids because it looks too much like thinking. Let's drift into that Martian orbit for a moment. Silent, steady, red below, black above. The high-rise camera hums to life, a billion-dollar eye staring into the cold. You can almost feel the anticipation, a mechanical eyelid opening in the thin sunlight. The image begins to build, pixel by pixel, line by line, translating photons into revelation, and then static. At first, it's subtle, a faint interference pattern, a digital shimmer, like someone exhaling across a radio signal. The engineers squint at their monitors. Maybe cosmic rays hit the sensor, someone suggests. Maybe solar noise. But cosmic rays don't make right angles, and solar noise doesn't repeat itself with architectural precision. The next image arrives, darker. The histogram spikes in places it shouldn't. The shape in the frame looks less like a comet and more like, well, something trying very hard not to look like anything. Its edges are clean, too clean. Shadows fall where there shouldn't be surface variation. And there, just faintly, a glint, a perfect 90-degree reflection. That's when the whispers start. The data team runs deconvolution algorithms to clean the image, and the results make it worse. Beneath the interference, faint geometric striations emerge, triangles, plates, grids. Not random, repeating, symmetrical. The kind of order that makes your brain uncomfortable because it feels deliberate. Structure, one analyst says quietly. No, her supervisor corrects. Artifact. But even as she says it, her cursor hovers over the same square patch again and again, as though hoping it will stop looking like a window. ESA's public statement comes fast and flat. The imaging anomalies are consistent with sensor interference caused by reflected solar radiation. That's bureaucratic. For, we don't know what we're seeing, but please don't ask. Internally though, emails start flying. The word structure appears 17 times in one thread, always in quotation marks, as if politeness could make it less alarming. Imagine being one of those analysts, zooming in until the pixels themselves seem to blink. The surface of 3I Atlas isn't smooth or cratered, it's tessellated, plates arranged in patterns too regular for chance. Some appear overlapping, others recessed, and in one frame, a faint seam runs along the curvature, subtle but unmistakable like a hatch. Of course, no one dares call it that. The official internal term becomes geometric albedo variation. It sounds safe, sterile, boring, but you can't unsee geometry. Nature loves curves, spirals, organic chaos. This looks like design. One engineer writes in her log, "Could this be an illusion from the imaging process?" Another replies, "An illusion that repeats itself identically across 3 instruments." There's no follow-up message. They try to replicate the interference on other targets. Phobos, Deimos, even an old asteroid. Nothing. Only 3I Atlas corrupts images this way. It's as if the object rejects observation, like it knows when it's being watched. The engineers half joke about it. The comet's camera shy, but the laughter is short-lived because the next transmission from High Rise contains another surprise. a faint electromagnetic pulse, perfectly timed with the camera's shutter, not a malfunction, a response, as though the act of observation triggered a reply, a pulse that says, in its own quiet way, "I see you too." In a locked sub-channel of ESA's network, a few scientists begin privately discussing the possibility of active surface modulation. They talk about the way certain materials can alter reflectivity based on exposure photonic metamaterials, adaptive nanostructures, the kind of thing still locked inside prototypes on Earth. But this is happening hundreds of millions of kilometers away, and it's working flawlessly. Publicly, the agency releases blurred grayscale stills, carefully cropped to hide the patterns. Enhanced contrast is cited as the reason for distortion. It sounds reasonable until you realize they've enhanced the darkness, not the light. They've made the object less visible, not more. The cover-up, if it is one, isn't about hiding truth. It's about buying time. You imagine the silence inside those offices, the soft tap of keys, the nervous glances toward closed doors. The engineers know what they've seen, but they also know how careers end. Better to let the pixels lie. Better to call intention an artifact and go home early. But the data, like truth, keeps finding its way back. Somewhere, late in the night, a graduate student overlays all the interfered images, stacking them like translucent slides. Slowly, a pattern emerges. Faint, angular, deliberate. A hexagonal lattice running the length of the object, segment by segment. She whispers, "This isn't random." Her mentor sighs and rubs his eyes. Then don't say it out loud. 3i Atlas drifts on, silent and unbothered, its surface catching sunlight in rhythms that cameras can't quite capture. Whether it's reflecting, refracting, or responding, no one can agree. But deep down, every scientist staring at those corrupted images feels the same creeping certainty. This isn't a comet pretending to be a machine. It's a machine pretending to be a comet. Let's turn our attention now to the silence that followed, the kind that hums louder than sound itself. NASA, China, and the UAE, three nations with instruments that could see every grain of dust on Mars, said nothing. No apologies, no delay statements, just an odd, synchronized silence from three sides of the planet. In the world of space science, silence isn't normal. These agencies are built to broadcast. They live for live streams, press briefings, and glossy behind-the-scenes videos of scientists smiling beside screens of raw data. They know the power of wonder and the currency of attention. So when three agencies went quiet at once, it wasn't caution. It was choreography. Words on hold, plans unfold, silence rings where truth is told. NASA's silence was the loudest. Their social media team, usually chatty as a cosmic talk show, posted nothing about Mars for 4 whole days. Their blogs, which can turn a dust storm into a cliffhanger, skipped over October 3rd entirely, as if the date itself had been erased. Someone even checked the public mission log for Perseverance. The entries jumped from October 2nd to October 6th, like a diary missing its most interesting page. In China, the silence felt different, colder, heavier. The China National Space Administration had been aggressively proud of Tianwen-1's achievements. For years, they'd released image after image, each with perfect captions and poetic flair. Sunrise over Utopia, Planitia, frost on the northern plains, wind prints in Martian dust. But now, not a whisper, no data, no mention of 3i Atlas. Even the usual state media outlets went quiet. It was as if someone had drawn a red box around the topic and labeled it, "Not for discussion." The UAE's silence was subtler, but just as strange. The Hope orbiter, designed to study atmospheric chemistry, had a reputation for cheerful transparency. Their official Twitter account usually posted daily updates in friendly tones, the kind that made space sound like an enthusiastic classroom experiment. But on October 3rd, that feed went dark too. Their next post, days later, simply read, "Operations nominal," a phrase so bland it might as well have been a sigh. 3 silences, 3 styles, 1 timing. Coincidence? Possibly. But coincidences, in the world of space politics, often have launch schedules. You can picture the meetings that weren't broadcast. NASA's Jet Propulsion Laboratory, dimly lit, engineers staring at telemetry on screens filled with too many decimals. A director taps the table, says, "We'll hold the release until we verify." But verify what? In Beijing, a senior administrator folds his hands and says, "We wait for clarification from partners." Clarification of what? In Dubai, someone simply deletes a draft tweet that began, "Amazing new observations today." Tweets unsent, secrets bent, silence hums with government. It's not conspiracy, not quite. It's coordination, an instinct born from shared discomfort. Because when data doesn't fit the model, you don't just release it. You check, you recheck, you call your counterparts and whisper through encrypted lines. Did you see that too? Maybe they all saw the same anomaly. Maybe it was something in the spectra, or the movement, or the light itself. Or maybe it was something far more mundane, like a misalignment in software. But the silence gave the anomaly power. People don't fear data, they fear gaps. Meanwhile, the internet did what it does best. Filled the void. Forums buzzed with theories. Maybe NASA discovered life. Maybe China detected radiation. Maybe the comet wasn't a comet at all. You can almost hear the world's collective keyboard clicking under the weight of imagination. Keys tap fast, rumors cast, silence breaks, but never last. Inside the agencies, the tone was less dramatic, but more anxious. Silence is a resource, a temporary one. Every day they didn't speak, the speculation grew. And so, communications teams drafted placeholder statements, just in case. NASA's draft began. Preliminary results are consistent with natural phenomena. China's began. Analysis ongoing. International coordination required. The UAE's version simply said, "We continue to monitor with interest." 3 drafts, 3 ways of saying absolutely nothing. But silence, like space, is never truly empty. It amplifies the faintest signals. When ESA spoke first, that silence turned reflective. NASA's restraint began to look suspicious. China's confidence began to look afraid. The UAE's politeness began to sound like complicity. And through it all, 3i Atlas drifted quietly, blissfully unaware that entire bureaucracies were wrestling over how to describe a fuzzy dot. You start to imagine each agency as a character in a play. NASA, the anxious perfectionist. China, the poker-faced strategist. UAE, the cheerful intern, suddenly told not to speak. And ESA, the calm older sibling who broke the tension by saying, "Fine, I'll go first." Roles align, stars entwine, silence speaks in grand design. Still, one question lingers. Why the synchronicity? How did 3 separate agencies, operating on different continents, decide independently to say nothing at the same time? Unless it wasn't independent at all, perhaps the signal came from somewhere above, not cosmic, but political. A quiet message passed through diplomatic back channels. Hold your data. wait for alignment. Matter. It's not that they were hiding something nefarious, it's that they didn't know what they were holding yet. And admitting uncertainty, publicly, is scarier than any secret. So they stayed quiet. And in that collective silence, humanity did what it always does. When faced with the unknown, it began to dream louder. Voices still, hearts fill. Silence grows but never will. And perhaps that's the strange comfort in it all. Even when 3 space agencies fall silent, the universe keeps talking. The stars don't pause for policy. 3, Atlas keeps moving, whispering its quiet story across the dark, while we, down here, argue over who gets to speak first. Descending into the crystalline depths of the Lake Baikal research station in Siberia, the world above becomes a muted memory, and the only sound is the rhythmic creak of ice shifting under its own immense weight. It is now late March 2026, and 3I Atlas has begun its final, silent slide into the dark sector of our orbit, where the sun's glare and the Earth's bulk conspire to hide it from our view. The James Webb Space Telescope took its final capture yesterday, revealing not a rock, but a shimmering, translucent veil that seemed to dissolve even as it was being measured. It is the ultimate ironic understatement to call this a departure, as those words are doing the work of 1,000 unanswered prayers tonight. You might believe that a story requires an ending, a definitive period at the close of a long and winding sentence, but the universe rarely grants us such closure. 3I Atlas is nothing like Oumuamua because it didn't just pass through our lives, it integrated itself into our collective consciousness, a dark mirror that showed us exactly how much we have yet to learn. The ancient Sumerian texts ended their descriptions of the winged disk, not with a battle or a revelation, but with a simple statement, and then, the sky was as it was before. We are returning to that state now, the telescopes cooling, the researchers returning to their homes, and the late-night transmissions fading into the static of the background radiation. As you lie there, drifting in the space between awareness and the deep, heavy pull of sleep, consider the final, unresolved mystery of this visitor. It didn't leave because it was finished, it left because we had seen enough. The question that keeps the night shift at the European Space Agency in a state of quiet awe is not where it is going, but what it left behind in our atmosphere, in our signals, and in the way we look at the stars. It is now late April 2026, and the data streams from the deep space tracking stations have slowed to a trickle of ghost signals and thermal noise. The object has passed the secondary orbital threshold of Neptune, its velocity increasing as it sheds the last vestiges of our sun's gravitational influence. There is a specific kind of melancholy that settles into an observatory when a target is lost to the void. It's the feeling of a conversation ended mid-sentence, leaving the air heavy with the weight of things left unsaid. Scientists at the Jet Propulsion Laboratory have spent the last 72 hours staring at the final high-gain transmissions, trying to decode a sequence of pulses that occurred just as 3I Atlas crossed the termination shock. It wasn't a message in any linguistic sense. It was a frequency, a resonance that perfectly matched the vibrational signature of our own planet's iron core. It's as if, in its final moments within our reach, the object reached out and felt the heartbeat of the Earth one last time. You might think that once an object leaves our sight, it leaves our reality. But 3I Atlas has left a scar on our understanding of physics that will take generations to heal. The anomaly of its non-gravitational acceleration was never solved. The question of its perfect, obsidian surface remains a mystery that mocks our most advanced material sciences. We are like children who found a titanium key in a sandbox. We know it is important, but we have no idea where the door is, or if we even want to see what is behind it. There is a dry irony in the fact that we spent billions on the James Webb Space Telescope to look back at the beginning of time, only to be confronted by something that was right in front of us, moving with a purpose we couldn't even define. Unfortunate timing for our sense of cosmic superiority, as those two words are doing a lot of work in the quiet halls of academia tonight. In the final reports being filed at the European Southern Observatory, there is a footnote that hasn't made it to the news. It describes a faint, lingering distortion in the space-time fabric where 3I Atlas once sat, a gravitational ripple that refuses to dissipate. It's as if the object left a footprint in the very vacuum of space, a reminder of its weight and its passage. Some theorists suggest it might be a communication relay, a lingering ear left behind to listen to our progress. If so, then every word we speak, every dream we have, is still being recorded. The conversation didn't end, it just became one-sided. The choice illusion is the most persistent of our comforts. We believe we chose to study the object, that we chose to name it, that we chose to let it go. But a traveler moving at 48 kilometers per second doesn't ask for permission. It moves with the certainty of a physical law. We were merely observers of an inevitable event, participants in a ritual of scale that has been played out across the galaxy 1 billion times over. The pattern is the message. As the last light of the sun fades from your room, imagine the cold, dark hull of 3I Atlas as it enters the interstellar medium. It is moving into a darkness so absolute that the very concept of sight becomes meaningless. It is at home there. It belongs to the deep places between the stars, the places where time is measured in the decay of protons and the cooling of suns. It is heading back to its masters, or perhaps it is its own master, a sentient machine god carved from the heart of a collapsed star. We will never know. And that is the beauty of it. The mystery is the only thing that is truly ours to keep. The night shift at the observatories is ending. The sun is beginning to touch the edges of the world somewhere else, far away from your bed. But for you, the journey is just beginning. The space between sleep and wakefulness is the only place where we can truly match the scale of the cosmos. It is the only place where the math of 3I Atlas makes sense. In your dreams, the object is still there, hanging in the black, a dark sentinel watching over the development of a species that is just beginning to wake up. The long, quiet sentences of the universe are still being written, and we are just the ink on the page. The pattern has been established, the warning has been delivered, and the choice, if it ever was ours, has been made. The silence that follows is not empty. It is full of the echoes of everything we almost understood. The orbit of 3I Atlas continues in the dark, a cold, dark sovereign moving toward a future we can only imagine from the safety of our beds. Close your eyes and drift with the orbit of tomorrow.